Okay, so here's some polynomials out of section 3.3, and we need to write polynomial functions that have these characteristics. So I noticed that for number 31, this is degree 3, and I notice I've got 3 zeros. So since there's 3 zeros and it's supposed to be a third degree equation, all of these zeros are multiplicity 1. So I'm just going to write the factors. Remember, if we were saying that x equals -2, then the corresponding factor is going to be x plus 2 equals 0. And the same deal, if x equals 1, then x minus 1 has to equal 0. And to make a long story short now, we know that if x equals 3, the other factor is going to be x minus 3. So we've got x minus 3 times x plus 2 times x minus 1. And they're telling us that the y-intercept, or the vertical intercept, the y-intercept is -4. Is it 0, -4? If I substitute in 0 for x, do I get -4? 0 plus 2, it's not looking like I'm going to. So in which case, that tells me there's some stretch factor that we got to account for. So a times -3 times 2 times -1. That has to equal 4. So a times 6 equals 4. A has to equal 4 over 6 or 2 over 3. And that's going to be the stretch factor. So that's what goes right here in front. That's my f of x. That's what you do with that. So for number 33, they're telling us it's going to be degree 5. So there's going to be a 5th degree equation if we expanded it all out. I've got some other zeros now, but now they're telling me about multiplicity. So this tells me these are like double roots or triple roots. I know in the graph it's going to, whatever the graph looks like, I know that x equals 3. That function's either going to come down and bounce off the x-axis from above, or it'll bounce off the x-axis from below. I haven't thought enough about that yet to know, but I do know it bounces. And then, of course, if it's multiplicity 3, 000, it's going to wiggle through. It's going to act like 1 over, or not 1 over. It's going to act like x cubed, right? So it'll wiggle through it like that, versus just passing through like a first degree. Okay, let me clean this out then. So let's do this problem. So I know that it has a root at 0, or a root at 3. So x minus 3 is a factor, and it's telling me multiplicity 2, so I have to square it. It'll act like x minus 3 squared, that parabola, and it has a multiplicity 2 at x equals 1, so x minus 1 squared. And then it's got a root of multiplicity 1 at x equals 3, so that's just going to be x plus 3, and because it's multiplicity 1, it just passes through the graph. And then I've got to see, is it equal to 9 when x equals 0? So if I do 0 minus 3 squared times 0 minus 1 squared times 0 plus 3, won't that be 9 will equal a times 9 times 1 times 3. So is 27a equal to 9? So a divided by 27, divided by 27. A equals 1/3. So that's what's going to be the stretch factor. Well, it's not 1/2, Dan. It's 1/3. Let's see. Let me fix that. Okay, so that's a polynomial function that'll approximate what's described in number 33. Okay. Then they change gears a little bit in number 40 and 35. Now they're not saying multiplicity, they're using the double zero. So that means, this means multiplicity 2. And a 000 means multiplicity 3. So 0 at x equals 5. So, I mean, x equals 1. So x minus 1 squared, and a 000 at 3. So x x minus 3 cubed. So that has degree 5, right? If we were to expand this out, this would be x squared plus something, something, something times x cubed plus something, 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 something. And then if you multiply, if we were to distribute that through, that'd be x to the 5th, and that's what we're looking for, 5th degree. Now the only thing we got to worry about is, does this pass through the point 2, 15? So if I drop 2 in for x, do I get an output of 15? Well, I'm sure as you figured out by now, we probably won't, so we'll have some kind of stretch factor going on. Some of the math ones work out this way. You don't need to do any kind of stretch factor. So let's see. So what's different about this one is they aren't telling us the vertical intercept. They're just telling us a point on the graph. So 2 minus 3. So instead of 0 in for x, we're substituting in the 2. There's an a here, and we want to see is this equal to 15. So that's going to be a times, well, let's see, 1 squared is 1. And negative 1 cubed is negative 1. And that's obviously not 15. So it looks like negative a equals 15. A must be negative 15. So that's what we're going to stick in front of this function. And that should be the equation. Of course, you can check the odd answers in the back of the book in these odd numbered exercises. And out at the that open text pre-calc site, they've got all the fully worked out answers, so that way you can check them there too. Hopefully this helps you do this kind of question.